Hello guys, today's topic is sequence diagram using UML. Definition: sequence diagram is a type of interaction model which shows how different objects of use cases are linked and work together in order. So the name shows sequence. Sequence means the flow of communication in sequence, or flow of instruction, or flow of activities between the two objects of use cases. This also means that we must have a use case diagram before drawing the sequence diagram, because the sequence diagram is the base for the objects, or we can say the objects are derived from the use cases. But remember that this does not mean that for every use case we must have one object. Yes, it is possible that for particular use case, or we can say that particular use case is mapped into one object, but it can comprise of many objects, several objects. So for example, if we have 5 use cases, so there is the possibility that the number of objects are more than 5. Timely communication and order of sequence is important in sequence diagram. If we compare the sequence diagram with the class diagram and use case diagram, so what's difference we feel? If we compare the sequence diagram with the use case diagram, so the one difference is that use case is the user interaction oriented diagram. That is how actor interact with the functionalities, and different use cases interact. But sequence is not there. In what sequence they are passing data. But here the actors are not necessary, but the objects inside the use cases are mentioned and drawn. And then the communication among the different objects for some purpose occur. If we compare sequence with the class diagram, so class diagram is a static diagram. It's not dynamic. In class diagram, we write the classes to which this object belong, and the attributes are written. The detailed functionalities, operations are written in class diagram, and different types of relations of one class with other are mentioned. Here we don't write attributes, we don't write the operations, the concrete details, and we don't mention the interaction or relation type, but rather we just write a sequence. Also remember that after drawing the use cases and then sequence diagram, we draw the class diagram, or class diagram can also be drawn before sequence. But these 3 diagrams become the base for the software designing. So 2 types of designing. One is the high level design, another is the low level design. High level design means the software architecture, the skeleton. So these 3 types of diagrams, especially use case, sequence and class, not helps only in defining the high level software architecture, but also become the base for the low level designing. And that design is assured, implemented by the developers. So in sequence diagram, objects are placed from left to right in sequence. So remember this. This is the standard that we will start from the left to right. Yes, reverse is also possible, but the initial start is beginning is from the left. What are the basics of sequence diagram? A sequence diagram is a type of interaction or dynamic diagram because it describes how and in what order a group of objects work together. So here we can say that how object works or working of objects is defined, or working of classes. Components of sequence diagram. First is the lifeline, which I will show you with the example shortly. Lifeline contains the object name. Suppose student is a object name that is participating in the sequence diagram. A message, a particular communication between two lifelines. Self message when communication of object with itself. So it is possible that object pass a message to itself. Reply message when object of one lifeline makes a back reply, which send message is reply message. So if object 1 pass a message to object 2, communicate with object 2, and object 2 back reply to object 1, then that is called reply message. Then we have further types of messages: synchronized messages, asynchronous messages. In synchronized messages, color of the message waits for the response back from the other object, while in asynchronous message, color of the message does not wait for response back from the other object. So this means in synchronized message, object which send message must expect the back response from the second object. For example, car and car keys. So note the expression in the square brackets. That's a guard condition. It's the UML way of saying if. So if the pressed button was lock, the car send itself request to carry out the lock operation. So this one object is a car owner who is operating the car, then key and car. So you can see the instruction start from the left to right. The message flow start from the communication start from the left to right. So owner get button press. This is the instruction send through a key, car key. Then process key message to the car. Then car, this is a self message. We talk already self message when communication of object with itself. So this is the self message of car to itself. If it is if the instruction is lock, this means here it is already written. So if the pressed button was locked, the car send itself a request to carry out the lock operation and the car will be locked. And then the message is sent. Remember that this is not a back reply. This is not a reply message. This is the forward message from car to owner. That is, two instructions are sent. One instruction is the blink lights, light blinks, which indicates the car is locked, and the beep sound. So car owner is informed in this way. Now take example of soda machine scenario. We have three components, or we can say the four objects. One is the customer who request. The front accept selection and cache display. Prompts like out of selection and use correct change, receive change from the registrar, register and makes it available to customer. So all these you can see the definitions of each object. I will explain it here. So customer accept cache selection. So front is responsible for taking the cache and selection. Then get customer input cache. So register object is responsible for taking this instruction and check availability of cold drinks. So this is a front through which the user get input, then cache is checked, and then dispenser object is informed, check the availability. So this is the back reply now. Back reply is from this object dispenser back to the register. There, yes, it is available. Then register object give message to itself. This is a self message. Update reserve means if somebody given more cache, so obviously the cache will be updated. And then this is the receive message. So receive is the receiving a cold drink through front object to the customer. This is sequence diagram for machine out of change scenario. If it is out of change, so this is the same message, this is the same message, and check for the change, return cache. So if there is no change available, so return change and display prompt use correct change. So if you have entered the less amount or change is not available, so this means there is no communication from the dispenser. This means cold drink is not given to the customer using via front. So this show there is something happening here. So this one object is responsible for taking and updating all the information of cache. This is the generic sequence diagram of soda machine. Customer, front, register, dispenser, accept cache, get cache input, then self message if cache is greater than price, means for example if the price of drink is $1 and you have input given $2, so yes, this is okay. But if it is not greater, then other message will be issued. Check for the change. No change, return. Transaction over, no change. So display prompt use correct change. Check availability of the cold drinks. Sold out. This is the second condition where cash is equal to the price. So if it is not available, this means the message will display the cash is okay, but drink is not available. So all the possible communication among these objects are seen here. This is another sequence diagram for point of sale. The use case diagram of point of sale is already explained in the previous lecture. So this is operator. So this is the first step. One, product entry. So for purchasing and selling, for both activities, product entry is necessary. So before purchasing, the operator must enter the product's detail, and then the supplier entry. So supplier information, who is the supplier from which the shopkeeper purchase the products, and then purchase ID is entered into purchase main. So purchase main contain the invoice number, the supplier ID, and purchase date, and the purchase detail include the detail all the products for the purchase main, and then product ID is entered to the purchase detail. This is the step 4, and in step 5 account is updated. Which account? The debit account and the credit account. So debit are actually the remaining amount and credit are the amount paid to the supplier. And then this is the uh, reply message to the operator. The a reply message to this object, and products quantity are updated. For example, if in stock the previous quantity were 10 and 3 are sold, so this means the remaining quantity will be 7. So this object communicate this object. Similarly, the operator enter the customer, and customer ID comes to salesman, and products from this object enter into the sale detail. Account is updated, and quantity product is also updated, but here is not mentioned. And this is when you enter the paid amount for each supplier. So this is a supplier credit, and this is a supplier customer credit. So eventually when time passes and you pay to the supplier or customer pay to you, so this is also enter from this object. So why this arrow from the so this is the direct arrow from operator towards the supplier account, and this is to customer account. So all the software will work in this sequence. So you must understood that when we design the high level architecture, so mentioning all the classes, components, and communication. So without communication and in sequence communication, designing the high level architecture is not possible. Sequence diagram for services, product, provider, and buyer. So the use case for this scenario, for this example, is already explained in the use cases. So now see the sequence diagram. So this is the login, enter phone number, then phone number is verified. This is service provider, who the service provider are those person who provide their services, and buyer are those who buy the services, and product provider and product buyer also work in similar way. So this is the back message, register yourself. So request for registration, and then register successfully. Then a person login, select a category is added, and in step 9 add rating, add location and language, and then details added. So in this sequence service provider module works, or we can say different objects of the service provider communicate. This is the product provider. So in similar way like the services, product is added, and this is the service and product buyer. So customer will log in and will enter the email and password. It will be verified, and then he or she will select products and services. Also check the availability in stock if it is the product buyer. So if it is available, so this means back reply will come, and customer will be informed that stock is available. Then check payment, and then confirming payment, and then order is pasted. So these are the different objects belong to use cases of the service and product buyer. So this was all about the sequence diagram. Thank you so much for watching my video. Thank you so much.